We've seen this idea of polymorphism a number of times this semester, and basically the same name has multiple meanings within our program. And now I want to look at 5 terms, 2 of which we've talked about quite a bit before, and 3 of which we haven't, even though the concepts are things that we have talked about. So the first one, by way of a review here, is overloading. And we've seen overloading when you have 2 methods or constructors of the same name that differ in method signatures. That's perfectly fine in Java. It's called ad hoc polymorphism. And Java just knows which one you mean by the method signature when you call it. So no problems there. We take advantage of that all the time. When we first got into inheritance, we started talking about overriding. So that is a form of polymorphism because there's a method by the same name in the base class and the derived class if we've overridden it. And Java has to figure out which one you mean when you call it. And we looked in quite a bit of detail at the idea of dynamic binding. So it's always going to go to the bottom of the inheritance chain and find the most specific version of a method when you have overriding in place. So again, 2 things we've seen before. The next term is shadowing. We haven't used the term, but we've dealt with this, and you've dealt with this from pretty much the first time you wrote classes that had constructors. So for example, here in this constructor for class A, X and X have the same name, so we've got polymorphism here. And we learned that you need to specify this dot X if you wanted to reference the instance variable X, because X by itself is going to be taken to be the most local reference possible. And in that case, the specific case, it's the parameter X takes precedence over the instance variable X. Easy enough to get around, but still a potential problem. You might not notice this every once in a while. I know we've all run into this where we didn't realize that we had some of this shadowing going on. It doesn't have to just be parameters. It could be local variables as well. So here, X is a local variable that gets Y times 2, and then we can have this dot X, which gets the value of Y. This one refers to the local variable only in F. This dot X refers to our instance variable. So really for this example, we're just looking at the new term, shadowing. Stop me if you have questions at any time here on this stuff. And so far, pretty straightforward, but now we're going to get a little bit messier here. So the next type of polymorphism, or problematic polymorphism, maybe we would call it, is hiding. And this is a situation where multiple classes within the inheritance chain, so a base class and a derived class, both have a variable of the same name. And we've got an example of that here. Wrong one. Polymorphic problems. That is a repository that you have access to. You're welcome to go grab a copy or just watch what I'm doing here. In this example, easiest way to understand hiding is to try it out. See it in an example. So let's do that. So what we have here is a class called hiding, which is only here to provide a main method. And we see that there must be 2 classes, A and B. We construct an instance of each of those. They must have some set X method. We call those, and then we print them out. So they must have some sort of meaningful toString method. Okay, nothing too deep there in the main method. A has those 3 methods that we need. So we need a constructor, we need a set X method, and we need a toString method, and there they are. They all deal with this instance variable called X. We deal with our situation here of shadowing when we say this dot X gets X in the set X method, so we get the right value set. In the constructor, we didn't need this dot because there is no shadowing there. If it doesn't find it locally, it'll look at your instance variables automatically via your this reference. Same thing down here. X in this case is this dot X, but we don't need this dot because there's no ambiguity. Now class B is going to extend A. And class B is also itself going to have an instance variable called X. In our constructor, we call our superclass constructor. So the one open class A, and then we set X to 20. In this case, what value of X are we talking about? Are we talking about the X that's here in class B, or are we talking about the X that we inherited from class A? Because they both exist. And that's the problem with hiding, is that if you give two different variables the same name in the base class and the derived class, they both exist. And sometimes you'll be referring to one of them, and sometimes you'll be referring to the other. And it's always going to be the one furthest down the chain, although we'll see that there's a little complication with that when we run this in just a second. In our toString method here, we see the way to get around hiding. If you wanted to get access to the variable X from your superclass, just like you can say this.x to get around shadowing, you can say super.x to get around hiding. That says, find a variable named X in the scope of my superclass, not just in myself. This one here is going to be the most specific version. So this will be the one that is here in class B. And I'll refer to that as is this one. If I want to run this thing, make sure it's all compiled up properly. What's going to go on here? So with class A, there were no surprises at all here. We constructed our class A. It had a value of 10 in X. Then I set it to be 30 in my setX method. And when I printed it out, I got that X is equal to 30. When I was dealing with class B, let's look at what the constructor does. The constructor calls super, which sets this variable X to 10. Then it sets its own variable X to 20. So super.x at this point is 10, and X in class B is 20. When I call setX, well, I don't have a setX method, so I've got to go up here into class A to find a setX method. Dynamic binding doesn't find anything in B, so it moves up the chain, finds one in A. Well, setX here it doesn't know about the X that's in class B. So the only X that it can set is the one in class A. So the thing that's going to be set to 40 is the X that B inherited from A, and the X that is declared in B itself remains the value of 20. And that's exactly what we see when we print it out here at the end. The value of X myself is 20, but if I look at my superclass for a value X, it now has a 40 in it. All right, so before we move on any further with that, does anybody have questions on this idea of hiding? So two things before I move on then. That's your second in-class question today. So in that in the Google Classroom document, we're going to say, where your answer is going to be in hiding.java, which instance variable X is modified by the call b.setX 40. So B has two instance variables called X. Which one gets set by 40? Well, we just saw it. So you'll mention that in your answer there. Second thing that I want to mention before we move on from this is if we were to ever draw a memory diagram in a case when we had hiding, we do need to represent both of those variables in our diagram because both of them do exist. There's an X that's associated with A, and there's an X that's associated with B. So if we RAB, we have both of them. And then the third thing is to point out that many of you have made this, have had hiding in your programs, and it led to things like really strange null pointer exceptions. We think back to some of the labs or programs that we've written where we were factoring code out of a few classes into, say, an abstract class or a base class. Think in terms of the, so maybe one of those falling or animated lines examples where all of them would have a done instance variable, for example. And if you forgot to remove the done instance variable from the derived classes, but you did add it to the base class or the abstract class that you extended, all of a sudden there'll be two different done methods. And depending on the context of the code you're executing, you might have, you might be referring to one or you might be referring to the other. So it is an error-prone practice to have uh, instance variables that hide instance variables in your in the class that you extend, but it is perfectly legal. So we just wanted to make sure that we're aware of what's going on with this. And I think that's it for the hiding topic, unless anybody has anything they want to add or ask.
I have a question.
Sure.
So, assuming that there's going to be a memory diagram on the final, I don't know if you've said that, but
I think it's safe to say.
yeah. So would like this be something that you would ask, like having instance variables in the same name, like this hiding concept?
I mean, it could be, but that would be a minor point on it if it did.
Okay.
So I would focus a diagram there more on the things that we've spent a lot of time on.
Yeah. So like not the things from today, likely.
They could appear, I suppose. The things from today, I think, are more short answer type questions or terminology, just knowing the terminology. And of course, it's open book, so you can go look up the terminology. But
Okay.
excuse me. All right, so if there is nothing further on that, let me move on to our next item here, which is